All right. Good morning, class. Oh, that's not where we're supposed to be in the slides. We're supposed to be right there. Perfect. You just got a little sneak peek of your activity. That's all that happened. Today we're talking about infectious disease epidemiology. I'll be totally 100 and say that I originally planned to move this lecture to Thursday anyway and have the activity be minimal for a myriad of reasons, partially because I wanted to goof off over the weekend, partially because I'm repping right now my Yale social and behavioral sciences. Infectious disease epi is not my forte. I can point you to people at Cal State San Marcos who it is their forte, should you feel so inspired by this lecture. Um, yeah, what I lecture here is probably the extent of my knowledge other than HIV research. And even that, I research the social dimensions of. However, um, I got a whole bunch of notifications from Cal State San Marcos about COVID exposure this week. So this is not the week to be learning by doing. So I'm happy that we're not gathering this week with regard to disease transmission, which we'll learn about. And I want you all to stay well out there. Should any undue and unwell situations arise, please just let me know. Like, obviously, I'm lecturing about this. It's in my values to give you time and space to heal and also prevent transmission. So, wishing you all the best. Stay well out there. And let's get into it. So, the first 3 weeks we talked about, I don't have like a last week slide because it doesn't directly pertain, but the last 3 weeks we covered the foundation of what you need to know about diversity and equity in the US. I'm pretty sure that's what the requirement's called. Obviously, disparities in equity and the social determinants of health will come up in everything that we talk about from here forward. And should not just be ignored, even when we start doing math, right? All that stuff still happens in the background and none of this occurs in a vacuum. But for the remainder of this unit, we're switching to a couple topic based lectures, this being infectious disease, because I can't send you out of here without knowing that. And then next week, we'll talk about behavioral epi, which will be pertinent to those of you that are kinese majors. And is what I'm getting my PhD in health behavior. So we'll talk about that. But today, we're talking about infectious disease. Any chatters? Feel free to chat and say good morning if you are here. It's okay if you're not. Infectious diseases. Infectious diseases are caused by a microbe or an agent, and we'll get over all the differences in the triangle. Oh, good morning, Ellie. And can be transmitted from host to host. Examples of infectious diseases that you may be aware of are influenza, HIV, and strep throat. This is different than infection. Infection is the entry and development or multiplication of an infectious agent in the body of man or animals. An infection does not always cause illness, and we'll talk about the differences between infection and infectious disease. Oh, so many of you are saying good morning. I hope you all have a good morning too. And there are several levels or gradients of infections. It's not just a binary, right? You could have a latent infection. We see this a lot with tuberculosis. You can have latent TB, which can either be dormant or inactive. It can be in your body but not causing infection. And you can also have manifest or clinical infection, which is you're exhibiting signs and symptoms. This is what you think of probably typically when you think of infection, like, oh, I'm hacking and wheezing and I'm snotty. That's a manifest clinical infection. Or I've got oozing coming out of different places. Sorry, it's too early in the morning for that. And then you might also know that you can be asymptomatic or a carrier, which is an individual infected with a pathogenic microbe who never exhibits overt signs or symptoms of the disease, but is still infectious. But is still infectious. Still infectious. There are a lot of STIs where you can never experience signs or symptoms, but you carry that disease. Not all pathogens cause disease. Like we said before, primary pathogens tend to produce disease, readily in healthy hosts. For an example, Mycobacterium tuberculosis. I think you all have to get a tuberculosis test to come to school. Maybe it's just grad school. But Mycobacterium tuberculosis is the causative agent of tuberculosis, the disease that we think of, which can affect various parts of the body, but most commonly the lungs. And if infected, this pathogen can produce disease in individuals with no underlying health issues. And that's what makes it a primary pathogen. Transitively, there can be opportunistic pathogens, which generally only cause disease or unusually cause disease when displaced to an unusual site or when the host has a weakened immune system. So for humans, why do we care? Or what does this look like? This one, I got the example of Candida albicans, serves as a prime example of an opportunistic pathogen. It's a fungus that normally lives in your mouth and in your gut and in other wet and gooey places in your body. And it's just chilling unless the host's immune system is compromised due to something like HIV. You are immunodeficient. Chemotherapy suppresses your immune system, or other similar immunosuppressive drugs. Then the fungus can cause disease. It can give you like oral thrush, or it can infect your innards and can possibly be fatal. But normally, it's just cool. So that is an opportunistic pathogen. Okay, so last semester I was feeling a little bit insecure about my infectious disease knowledge. I feel much better about it now. But I went on the website Giant Microbes. I'm not sure if you know about this. You can purchase there's some my infectious disease friends really love this and like got their like microbe of research as like a graduation gift for their MPH. So there's a website called, not sponsored, Giant Microbes, where you can buy plush iterations of your favorite microbe if you're into that. And I thought that it would be a little bit more engaging to give you the cute plush versions of what they look like versus like the microscope slide. So there's some plush toys. And that's just what it is. The properties of pathogens and microbes associated with disease production. All pathogens are not the same. And what do we mean when we talk about them? And how do we describe them? The first adjective or property that we're going to talk about is infectivity. So yes, we're talking about infectious disease epidemiology, but there's different levels of being infectious. And when we talk about infectivity, we're talking about the capacity of an agent, which is the virus itself. Just we'll better define it soon, but the virus or microbe itself, to enter and multiply in a susceptible host. The common cold, oh, it's so cute and blue. Has high infectivity, right? I could breathe on you from 8 feet away or give a little sneeze, and it could also enter and multiply inside of you from doing the same thing. HIV, on the other hand, has low infectivity. It has to enter your bloodstream to be able to multiply in a susceptible host. So normally we only see it sexually transmitted or through injection drug use, right? Sharing needles is how bloodstream to bloodstream activity would happen. So we say that the common cold or rhinovirus, which is the virus that causes the common cold, has higher infectivity, is more infectious than HIV. You may think, hey, HIV is more fatal, HIV is more severe. That seems a little counterintuitive. It's more virulent, and we'll get there. So then next is pathogenicity, and this is the capacity of agent to cause disease. This is in line with what we were saying before about primary and opportunistic. This is in line with that. Is that rabies is really serious. If you ever touch a bat, and I have been this person, you need to go get a rabies shot, just in case. Because if that bat did have rabies, it's a highly pathogenic pathogen and will cause disease. If that bat had rabies, you will also get rabies. That's why you see so many rabid animals or hear about so many rabid animals. It also has high virulence. This is why you have to go get it so quickly. We'll get there. And then the other intransitive is Propionibacterium acnes. Has low pathogenicity. It's the bacteria that causes pimples. And it's just on your skin, and sometimes it'll cause a pimple, but not most of the time. So that's the difference. The capacity of the agent to cause disease. And then virulence. Virulence is the speed with which an infectious agent causes its host, or you can think about it as the severity of disease. Ebola has high virulence, so does rabies. Ebola has high virulence. If you get it, you will die. If you get it, you will probably die. It's gonna do a number on you. That's the scientific, virulence is the scientific word for this disease is gonna do a number on you. Versus Giardia lamblia has low virulence. Giardia is a waterborne pathogen, I'm pretty sure, that you can come in contact with, and best case scenario, nothing happens to you. Worst case scenario, you get crazy diarrhea. Still unpleasant, but less virulent than death. So, come back to this slide, feel free to reference it. Those are 3 properties of pathogens and microbes that you could talk about. Another distinction that we'd like to make is the difference between disease, signs, and symptoms. Okay. So disease and the microbial cause are distinct. Just like we said, not all pathogens cause disease and can be inside you and still not cause disease. Probably the one that I've misnomered the most is salmonella. You think like, oh, you eat this raw egg, you're going to get salmonella. Technically, you're not. You're going to get salmonellosis, which is caused by the microbe Salmonella typhimurium. This is a good one to know as well, that HIV is the virus that can cause AIDS. Yeah, and that the flu is caused by the influenza virus. So those are distinct. And then a sign is any objective evidence of disease, and a symptom is any subjective evidence of disease. So a sign, these things are all measurable. I went to the doctor and my fever was 102.5. My sister has a fever right now and it's 102, so I'm really worried about her. Or you're anemic, or we can observe your decreased CD4 T cell count. Or we can see and document that you're getting opportunistic infections. We can track your stool. The doctors can measure that objectively, right? That's a sign. Versus a symptom. These are subjective, still matter. They do matter and are part of diagnosis and understanding, and are obviously part of the experience of infection. But they are all subjective. We can't necessarily see as healthcare professionals how tired someone is, how achy someone is. We have to ask them, what is your pain on a scale of 1 to 10? They have to tell us that they're tired. They have to report headaches. How bad are your cramps on a scale of 1 to 10? So that's what we mean by subjective. Is that we rely on their experience to understand it. Is that clear? Did we know that difference before? Signs versus symptoms. Now, probably there's other places where you can take entire history of epidemiology classes that go over human geography and population change. We're just going to touch on the epidemiologic transition. This is important to know. Is that in the US, this happened in the 20th century. That the leading causes of death transition from infectious and communicable diseases to non-communicable and chronic conditions. And it should be scary because this has been walked back upon a little bit since I got into public health, since I learned about this concept. Is that way back when, with less infrastructure, more people die very early on in life from infectious disease. So the mortality rate is higher. And this is from communicable diseases. So this is infectious disease, and this is, they call it lifestyle related, but let's just keep it chronic disease or non-communicable disease. It used to be that way more people died of infectious disease. It also used to be that they died way earlier, in like their 40s. Now we're living long and we're dying of different things because we've pushed off, at least we've tried to, the burden of infectious disease in the population. So in stage 1, infectious disease, malnutrition are leading causes of mortality and morbidity. Then we get improved nutrition, right? Less foodborne illness and public health. We've got good water infrastructure. Now we have an increase in non-communicable diseases. The global food chain is taking over. We're more disconnected with our food. We have increased fat and caloric intake, widespread tobacco use. People are stressed. People are working. People are coping. And now non-communicable disease deaths will pass those deaths from infection and malnutrition. And then we delay eventually those chronic diseases, right? We do want people to live long and healthy lives, so life expectancy extends. And now we're in stage 5, potential resurgence of infectious diseases due to globalization. We'll talk a little bit more about that. But that is what we mean by the epidemiologic transition, is that infectious diseases are no longer the leading cause of death, and in the US that occurred in the 20th century. All right, there's your history lesson. Let's talk about disease transmission. So I've been saying agent. What do I mean by that? The epidemiologic triangle, I actually don't love this picture, and I'll tell you why, is a model used to explain the etiology, or etiology is the study of causes of infectious disease, and degree of infection and disease severity are determined by the host's ability to fight off the infectious agent. And when we talk about environment, we're talking about, it could be biological, social, cultural, physical. So the agent is the cause of disease, or it's like the bad girl. It's the bad girl in our story. And it could be a virus, bacterium, fungus, parasite, any microorganism that can cause disease. And then the host, this is a tick, and I think of a tick more as a vector. So just slap a picture of my face here. A host is us or any organism that can harbor the disease, and the degree of infection and the severity of the disease are determined, like I said, by the host's ability to fight off the infectious agent. Things that matter are age, right? If you're older, you're not as able to fight off infection, genetic makeup, and immune status. And then environment encompasses everything external that influences the interaction between the host and the agent. It can be biological, like the presence of water or air quality, social and cultural, such as living conditions and hygiene practices, or physical, including climate and geography. And the last key player in this triangle, or tangential to it, is the vector. Vectors are essentially the transport mechanism that carries the agent from the environment to the host. Like a taxi for the pathogen. So mosquitoes are very common vectors for things like chikungunya or yellow fever. And then ticks are the vector if I were to get Lyme disease. It's usually because you got bit by a tick. So wear your tall socks if you are to go out in high grass. Okay. Now we're getting more nitty gritty about how do pathogens cause infection, and this is the chain of infection. We're going to start right here in the reservoir where germs live. The reservoir is where the infectious agent normally lives and multiplies. Let's take the example of the flu or the flu virus. The primary reservoirs are infected humans and, to a lesser extent, birds and pigs. You do hear about swine flu, you hear about avian flu, right? And infected individuals can harbor the virus in their respiratory system even before they show symptoms, making them more effective reservoirs for the spread of the virus. The portal of exit, then, for the flu is the respiratory tract. You sneeze, you cough, you talk, and little droplets of the virus are expelled into the air. And then the mode of transmission refers to how the infectious agent travels from portal of exit to the reservoir of the new host. And influenza can be transmitted through direct contact if we're touching and shaking hands. Oh, one of your TAs. I didn't make my bed today because your TAs are really cozy in the background. You don't have TAs, they're my cats. Oh, good kitty. Where was I? Mode of transmission. We could shake hands and transmit the flu. We could touch the same doorknob. We could touch the same phone and transmit the flu. And droplet transmission, of course, like when you sneeze or talk, if you just inhale that. Have fun with the flu, right? And then portal of entry. This is the way that the infectious agent enters a new host. So your portals of entry for the flu are going to be the mucous membranes of the nose, mouth, eyes. Flu in your eyes. And wherever the virus lands, depending on its infectivity, it can invade the body, right? And then a susceptible host is an individual who lacks immunity to the agent and has factors like we talked about, a weakened immune system, or they're old, or they're young, in this case, that make them more likely to succumb to the infection. And then once the virus enters the body, it attaches to and invades specific cells in the respiratory tract, beginning the infection process. And once inside, the agent, the influenza virus, must evade host defenses like the immune system and successfully multiply to be able to continue the cycle. Right. Oh, good. We did get movement with this. Okay. 3 forms of disease transmission. And there is a question on your quiz about this. And I'm just going to tell you now that you should think about this. Different ways that you can transmit disease are vertically. My PhD dissertation has to do with vertical transmission of HIV. If a mother has not gone through antiretroviral therapy and has HIV, there is possibility for mixing of fluids, either during live birth or through breastfeeding, that HIV can be vertically transmitted. So can syphilis. Congenital syphilis should be the rate of congenital syphilis should be zero. But it's not because of poor screening. So you can also transmit syphilis vertically, transmit from individual to offspring. I think about this a lot, but that's pretty much the only time we're going to talk about it in this class. But then there's also horizontal. This is usually how you would be. I mean, you're out in the world and you're only given birth so many times, right? So more often, horizontal transmission within the same generation. You can transmit directly, which is person-to-person contact, or droplets. Either we are shaking hands, you are having sex, you are breathing, you're sneezing, right? And those can all, the droplets are hitting your eyes. That's direct transmission. You're right up in that person's face, or other orifices transmitting disease. And then indirect is contaminated objects. We touch the same doorknob. Again, lots of things like, sorry, I'm thinking of like the middle school STI from a toilet seat. Usually things are not that pathogenic, infectious. But contaminated objects like doorknobs, depending on the infectivity of the disease. A common vehicle, food or water. There are lots of people who contact trace and are like, oh, you're having an outbreak of some diarrheal infection. Let's try and figure out what you ate and see if we can contact the other people who ate the same thing. Or drinking the same source of water and we get a stomach virus. Airborne. This is different from person-to-person contact. This is like we're all the way across the bus. This is like a very airborne disease. But you can see how for airborne, masking is going to change the amount of droplets in the air. Vectors, like we said, ticks or animal reservoirs. If you're hanging out with all the swines that have swine flu. Or eating infected meat. So there'll be a quiz, or there'll be a question about that on your quiz, if you don't already have it pulled up. There will also be a question about this on your quiz. Reproductive number. So this is how we measure infectious disease spread. The reproductive number. And that's how many people does each case infect. So if I'm sick and I get 10 of you sick, the reproductive number is 10. Um, but if someone else only gets 8 people sick, then the reproductive number is 9 because I infected 10 people, they infected 8 people. Now we're looking at 9 people. And all of those 18 people are probably going to go on to infect an average of 9 people. That's very infectious, super infectious. And we're infecting more and more and more people. So the epidemic will go on, right? If, here's me and my friend Jim. I infect 1 person, Jim infects 0 people. The reproductive number is 0.5. Then the epidemic will go away. Because then, if the 1 person that I infected either does or doesn't infect someone, the epidemic will... We're not infecting any more people. Right. If I even infect 1 person, it still keeps going. Or if the average person infects 1 or more people, then it keeps going. But if they infect less than 1 person, then the epidemic will assuage. It'll be attenuated, right? Okay, so the index, this is like patient X and what you think about, is the first case identified. And they're off over here. And then the primary is the case that brings the infection into the population. So their reproductive number is 4 because they're infecting someone. This person's immune, so good for them. And then these are all their secondaries, people that are infected by a primary case. This person is subclinical, which means they don't have signs or symptoms. How spooky, scary. And they can still affect a tertiary, which is someone who's infected by a secondary case who then will have a clinical case. So, things to think about. Does that make sense? The reproductive number, if it's less than 1, it goes away. Okay, let's talk about emerging and re-emerging diseases. Okay, so emerging and re-emerging infectious diseases are defined as a newly identified infectious disease or a known infectious disease that is either a new strain or rapidly increasing in incidence, geographic range, or pathogenicity. Lots of stuff contributes to emerging and re-emerging infectious disease. Like, I think I've scared you all with, like, how these all get around. So let's talk about what's actually happening. Deforestation, urbanization, we'll talk about climate change, can alter the habitats of humans, animals, and vectors, such as mosquitoes, leading to increased interaction and the spread of disease from animals to humans. Very stressful trade situations with exotic animals can increase their stress and their ability to harbor and transmit disease. Increased mobility and international trade can rapidly spread infectious agents across the globe. We're still bringing rats and ticks along on ships, whether we want to act like we are or not. And so diseases that were once confined to specific regions can appear in new areas because of mass global trade. Antibiotic resistance as well. I had a whole unit on this in my master's, which basically concluded in if you ever get prescribed antibiotics, take the whole course, and here's why. The overuse and misuse of antibiotics in humans has led to an emergence of antibiotic-resistant bacteria, right? Even if you start feeling better when you've got a UTI and you take your antibiotics for 2 days and you're like, wait, but I was prescribed this for 10 days, it's so that the remaining microbes don't develop a resistance to it. You got to shut them all down. And antibiotic resistance makes previously treatable infections more difficult to manage, which can become very problematic on a population level, right? And then changes in human behavior, such as dietary practices, sexual practices as well, drug use, can contribute to the emergence of infectious disease. Examples of emerging infectious disease is COVID. Re-emerging, I think Zika kind of toes the line between emerging and re-emerging. But re-emerging infectious diseases, like we got the bubonic plague back, we got measles back, we got mumps, because of declining vaccination rates Yeah, measles. That there was measles outbreaks in Disneyland. That's a reemerging infectious disease due to declining vaccination rates. Like, we have the means to control these diseases. Or microbial evolution. Pathogens can evolve new strains and become more virulent or capable of evading immune response. Like swine flu and avian flu. Y'all remember those when y'all were young? You might be too young. But that's microbial evolution. That's why you get the flu shot every year, right? Evolution. Or changes in public health measures, reductions in funding for public health programs, changes in mosquito control strategies, or weakening of public health infrastructure can all lead to the reemergence of diseases such as dengue or cholera. Crazy stuff. Let's you like looking at pictures. So here's some newly emerging hantavirus, I think, is on your activity. All the different flus, and then emerging and reemerging. Zika kind of toes that line. Lyme disease, this comes from Lyme, Connecticut. West Nile virus, nowhere near the Nile anymore. You got the plague back. Zika's newly emerging now in Africa. All type of fun stuff. Chikungunya is on your, what's it called? Your activity. Oh, more giant microbes. How cute. Emerging and re-emerging infectious diseases, and the biggest bulk of these are zoonotic diseases. 75% of emerging diseases, infectious diseases, are zoonotic. This is mad cow disease. This, I think, is the swine flu. And this is Lyme disease. So there you go. Zoonotic diseases originate and are sustained in animal populations. Reservoirs include wildlife, livestock, domestic pets, and birds, right? Birds can be those reservoirs for avian flu. Pigs are the reservoirs for swine flu. Cows are the reservoirs for mad cow disease, so on and so forth. And these are the ones we're concerned with are transmissible to humans. Globally, zoonotic diseases cause 2.5 billion 2.5 billion, I guess, cases of disease, and 2.7 million deaths per year. Transmission of zoonotic diseases to humans can occur through various pathways, including direct contact with infected animals. Yo, this happens a lot at state fairs, because, like, animals have just traveled, people have just traveled, the animals are under duress, there's live butchering near restroom facilities. So that's exposure to contaminated environments, ingestion of contaminated food or water, vector-borne transmission. Again, deforestation and habitat destruction exacerbate this. You're stressing out the animal and making it travel where it's not. So that exposure to a new environment can cause evolutionary changes that can cause disease. Climate change, global travel and trade, like I said, changes in agricultural practices, like slaughtering practices are pretty important, and biodiversity loss. Biodiversity maintains our risk of disease spillover. And instead, we're all eating the same corn. Okay, speaking of zoonotic diseases, where did HIV originate? HIV is really interesting. It spreads like an infectious disease, but sort of needs to be treated like a chronic disease. And it is important that you know where it originated and how. HIV entered the human population from primates, which harbor a related virus called simian immunodeficiency virus. If you ever go to cat shelters, sorry, this is just like my point of reference. You can also have FIV, feline immunodeficiency virus. So different ones for different animals. But we got it from our near ancestors. And this probably occurred during butchering / consumption of monkey meat in Africa from eating chimpanzee meat. I have a tangent that I'll go on next time. Next slide. I'll go on a tangent. And new viruses are still being transferred from primates to humans, and have the potential to cause new diseases and epidemics. So, the habitats and the ecosystems that monkeys, specifically primates, exist in are so important to maintain. One of your quiz questions is this: where did HIV originate? So HIV-1 jumped from chimpanzees into humans through meat consumption, and then HIV-2, similar thing, originated in sooty manga bays, and is responsible for fewer infections than HIV-1. And there's the giant microbe for it. Okay. Anthropozoonotic diseases. I'm just going to take a break and go on a tangent. I started watching, if you've ever watched Alone on the History Channel, it's also on Hulu. At least I watched the first season on Netflix, and now I'm watching Alone Frozen on Hulu. Anyway, they put all these survivalists out in some really remote, tough area as it turns to winter and see how long they can survive. They get like the essentials, they get things for warmth, and they get like a bow that they can bow hunt with, and they get like an axe that they can cut down trees and build shelter with, like doing the real survival shit. And I'm watching Alone Frozen, and they've all got their shelters built, and now it's a matter of catching different meat and animals. For the most part, they eat mussels, and they can fish with like just a hook on the line. They're building traps to try and catch hares and stuff. One of them caught a squirrel, and there's no cameras out there. They have to record all their own shit, but then we get little tidbits of like survival information across the bottom. And this woman who ate the squirrel was like, yeah, this squirrel, and then it flashes on the bottom of the screen like, oh, she could get like salmonella from eating the squirrel meat. She could get A, B, and C disease. And I was like, oh yeah, right. People don't normally eat squirrels, and she could get disease. So there you go. That's my zoonotic disease in real life tangent. Diseases can move back and forth, changing characteristics in the process. Approximately 26% of human pathogens are transmissible to animals. This is me Googling, can my cat get COVID? The answer is yes. Your cat can get COVID. It's anthropozoonotic. Other infectious diseases of humans that can infect animals are herpes, TB, measles, the flu. Your cat can get the flu. Salmonella, again, squirrel meat can have salmonellosis. And polio. Okay. And the reasons for emergence, better detection. So, yes, you can be like, oh, it looks like rates are increasing over the past 10 years. Like, we must be doing a lot worse in terms of, like, animal trade or something. That could be true, but it also could be that now we better understand. It could just be an artifact of better detection. We'll talk about screening a little bit. Human factors, I said this. Population growth, now we need food more quickly. We need more. Food production with stressed out cows, deforestation, stressed out animals are leaving. Travel, diseases can move different places far more easily. Environmental factors such as pollution, you can have a polluted food source or a polluted water source. War can completely strip an area and stress people out so that they're more susceptible to disease. Environmental disaster, due to climate change, I don't love calling these natural disasters because to an extent we are causing them. Environmental disaster can completely wipe out an area and mess up an ecosystem. Weather pattern changes and climate change, we'll talk more about that. And animal factors, altered behavior in new habitats, right? If they're in a packed market being traded, kept in a cage, and they're snarling and they're stressed, they're probably biting new species, different species, right? And changes in population balance. So all these things can cause emerging zoonoses. Over half of known human pathogenic diseases can be aggravated by climate change. If you want to read this review article, it's linked here. As I'll just go over the top 3. As global temperatures rise, so does the habitat suitability for vectors like mosquitoes and ticks. They're not only expanding their geographical ranges, but are also becoming active for longer periods of the year, which creates more opportunities for the transmission of diseases like malaria, dengue, Lyme. And warmer temperatures can speed up the life cycle of pathogens within these vectors, leading to more frequent and severe outbreaks. So that's warming. Precipitation then can change in terms of both heavy rains and extreme droughts, which play a role in the spread of waterborne diseases. Heavy rainfall and flooding can overwhelm sanitation systems, leading to more contaminated drinking systems with bacteria and protozoans, leading to outbreaks of cholera and giardiasis. On the flip side, drought conditions can concentrate pathogens in shrinking water supplies, which means that you have less clean water to drink from, right? And then floods and droughts can also have direct and indirect effects on the spread of infectious diseases. They can displace populations, creating conditions for disease transmission. They can lead to poor hygiene and sanitation, which increases the risk of disease. And all of this facilitates the spillover of zoonotic disease. So, over half. There's a concept called One Health. I don't have a slide on it, maybe I should, which does tie all this together, that to maintain human health at a population level, we have to combat climate change actively, and be environmental stewards. So if you're interested, One Health. Okay, disease prevention. This is from your book. This is from your book. The way that we prevent is through screening. Well, one way that we prevent is through screening. Public health systems do most prevention through screening. Obviously, you can do prevention, like I just said, by preventing climate change and then therefore preventing the onset of disease in the first place. And that would be a form of primordial or primary prevention. Screening. There is a time and a place that you can make screening useful, right? Like, if I already have this disease, is that just diagnosis? No. You can have disease and have it be detectable through screening before you would know, before the patient would present with symptoms. This is when it's helpful to screen, right? There's this whole period of time that varies for each, the windows differ for each disease, but the screening is useful, that you would have a detectable disease, be transmissible, but not present with symptoms yet, and therefore wouldn't know about your own transmissibility if not for screening. All screening ideas are not the same. Oh my gosh, when I was taking epi in my master's and learning about this in my master's, that was when Donald Trump was like, we have the tests and they're beautiful. I was like, oh, there's so much more nuance to avenues of screening, right? You've probably been screened for things in your life. You've definitely been tested for COVID at some point in time. If you are a female and 24, you've gotten a pap smear. You've been screened for cervical cancer. You've probably been screened for other diseases in your youth. Okay. There are 4 test characteristics of screening and diagnostic tests. Like I said, all screening is not the same. The window of when screening is useful differs. The purposes for which we screen differ. Some it is for like diagnosis and transmissibility of the individual, and some it's for other purposes. These are the 4 characteristics. In your master's, if you get an MPH, you have to learn how to calculate these, and I won't make you do that. And you're welcome. But you do have to know what these are and understand it well. Your book also tells you how to calculate them and gives an even more thorough explanation, so I really do encourage you to read the chapter. In the book, I think it's chapter 11. It's on your syllabus. The 4 characteristics are sensitivity, Oh my gosh. Specificity, positive predictive value, and negative predictive value. Okay, sensitivity is the probability that a patient tests positive given that they have the disease. A sensitive test would ensure that almost all individuals with the disease are identified and not missed. You'd have very few false negatives, right? Whereas specificity is the probability that the patient tests negative given that they do not have the disease. A test with high specificity will have a low rate of false positives, meaning that it rarely misclassifies healthy individuals as having the disease. Now, every screening test, every diagnostic test has both of these things to a different degree. And it can be tweaked with, like the spit test in COVID versus like the schnoz test have different sensitivities and specificities versus what they do to the wastewater in the dorm. Like they test your wastewater for COVID. Different sensitivity, specificity, right? And there's situations where we would want to value one over the other. Pertinent examples being a really rare disease, We would probably want more specificity in that test. If it's a rare disease, maybe not a severe one, we don't want a whole bunch of people cropping up with false positives and getting worried. Obviously, we want a sensitive test as well to correctly identify people who do have the disease, but specificity we'd prioritize with a rare disease. Versus if I ran a blood bank and I had to screen all the blood for HIV, I would want a more sensitive test. I can have no false negatives, right? So I want the most sensitive test possible, and if we end up throwing out some good blood, that's an okay trade-off in order to have very few false negatives. More sensitive test for a blood bank, right? Does that make sense? And then positive predictive value. You'd need the prevalence. You need to know what your population is and have numbers to be able to calculate these predictive values. So that's the caveat. And I know that these things can seem very similar, but if you do the math, they're not. A positive predictive value indicates the likelihood that a person actually has the disease given a positive result. And again, you need the population prevalence of the disease to be able to calculate this. The rarer the disease, the lower the positive predictive value for a given level of sensitivity and specificity, versus negative predictive value, which is the probability that you do not have the disease given that you tested negative. And a high negative predictive value is particularly important in screenings where the goal is to assure individuals of their disease-free status. So, if you feel like you have a good handle on sensitivity and specificity, that's what I want you to leave with. And then the other two, go to the book. Now, I've touched briefly on, I've talked about prevention. And you're like, Marina, how the hell is screening preventive if I already have the disease? It's secondary prevention. Remember, we're talking about population health. For the most part. And also, it could help you not have debilitating disease, right? So primary prevention, we're preventing the onset of disease or injury. A lot of your interventions that you're writing about in your Unit 1 homework, like I want more farmers markets, I want healthier food available to children at school so that they don't become obese, so that they don't develop metabolic risk, right? You're preventing it outright. And that's what we'd love to do if we can. With screening, we're in the land of secondary prevention, okay? This encompasses efforts aimed at early detection and intervention to limit disease and disability. Not only are we trying to prevent additional transmission, but we can help you if screened. Normally, you'd get treatment here. You'd start getting treatment right here. And that can prevent the amount of time that you are sick without treatment and therefore impacted by that disease, right? And then tertiary. This is more rehabilitative, like physical therapy is tertiary. Measures aimed at re-education and rehabilitation after significant pathogenosis has occurred. If I have a stroke, but I'm really trying to maintain my quality of life. Tertiary prevention of like further damage. But in screening land, I should have put like a red box around this or something. We're talking about secondary disease prevention. Does that make sense? Contact tracing is a form of disease prevention. In Connecticut, they did pretty well. At least I think they like got all the infectious disease epi and PH students to be contact tracers, and they were awesome at it. But I think it started too late. The efforts weren't coordinated enough. And so the idea behind contact tracing, the execution was a little clunky. But if you were ever contacted by a contact tracer, and like I just got this email, technically I'm being contact traced. Contact tracing is a process of identifying, assessing, and managing close contacts who are potentially exposed to disease to prevent further transmission. They say, hey, Marina, one of your students has COVID, and you might get it. And so they're like, do you feel, can you go take a test? And if you do have COVID, we'll tell more people. And guidance is based on the disease, right? So for, they have you do this for STIs as well. And it's usually just go in and get treatment. But for COVID, it's do all the transmission prevention metrics that you've learned. Mask in public, get food delivered if you can, physical distancing, with the ultimate goal to limit community transmission of the disease, right? And I just gave you the rap sheet, but here's more. Yo, this Jubilee video, I had a phase where I watched a whole bunch of Jubilee videos. I should make this. Y'all should watch this. It's incredible. Strategies for managing infectious disease risk. Quarantine and isolation. Obviously, I stay inside. If I'm sick, I stay inside. I get my Target groceries delivered to me. I run up my DoorDash bill. Or I have friends drop off casseroles. Sanitation. Wash your hands, especially if... usually it's hospital infections like MRSA that are, on hand sanitizers. They say this kills 99.9% of bacteria or whatever. You still got to wash your hands because there's some that stay physically on your hands, like MRSA. That can be some of the most virulent. Vector control, pesticides, minimizing standing bodies of water. This matters in San Diego. Yo, we have big mosquito problems. We had the ankle biter mosquitoes. The best billboards that I see, I live in a neighborhood with a lot of billboard advertisement. The best ones are the ones that tell you to pour out your standing water. My cats have a water fountain that like flows the water because standing water is where mosquitoes lay their eggs that turn into larvae that turn into more mosquitoes, right? So as a form of vector control in San Diego, pour out your standing water. Vaccination, obviously. We've talked about the measles outbreak that could have been prevented and reemerging infectious disease. But of course it also applies for COVID, so go watch that if you're intrigued. Antibiotics and antivirals to treat illness. Again, populations of pathogens become resistant over time, so finish your course of antibiotics should you be prescribed them. Masks and social distancing. We saw the airflow of the droplets before, and obviously if I'm not even within 6 feet of you, it doesn't matter in the first place. We had this circle chain of transmission before. Some ideas for prevention strategies, depending on what disease it is for every single step, is that you can pasteurize the pathogen away if we're talking about like food. In the human reservoir, I can stay alone. I can also practice safe sex. Use hair nets for things like lice. And immunize, right? Then I'm immune and we can teach each other. So those are prevention strategies. Something that I think people don't know about, if you don't know a lot about HIV, is PrEP. Have you heard of this before? Very clunky name. It's called pre-exposure prophylaxis, but that really is what it does. But for short, you can call it PrEP. Is that it's a method to prevent HIV infection among those at substantial risk. So if you are a person who injects drugs, I'm trying to advocate for women in violent relationships. We see a lot of HIV incidents among women in violent relationships. If you are a man who has sex with men, if you have multiple sex partners, if you have a sex partner who has been incarcerated, those are substantial risk for HIV infection. You can take a single pill every single day, which reduces your risk of infection by up to 92%. That's huge. You can be, right, pre-exposure. If you're taking this pre-exposure and you are exposed, poof, nothing. So this is one of the strategies to prevent HIV transmission that is low-key slept on and not invested enough into, because yes, you must commit to taking the pill every day and seeing a healthcare provider every 3 months. And without insurance, it costs $1,300 a month. So the answers are out there. If we are willing to invest in them and research them better. Herd immunity. I hope that this is something you're all aware of. If it's not, it's a great reason to get vaccinated. Like we were talking about with opportunistic pathogens, not everyone can have a pathogen enter their body in a way that wouldn't be debilitating to them, right? So not everyone can get vaccinated. Those people rely on something called herd immunity or community immunity, which happens when a large portion of the population is no longer susceptible to the disease. Now, this can happen via infection or vaccination. If all of us get vaccinated, we're ballin'. But you can also have natural immunity, which I know is like a big old buzzword, which happens with things like chickenpox. If you've had chickenpox once, you don't need to get the vaccine. Because you develop natural immunity. Now, you don't develop natural immunity without getting the disease. So you probably do need a vaccine if vaccines are recommended. And some infections, like measles, require 95% herd immunity to not be wildly infectious, which is how we see that outbreak at Disneyland. So herd immunity is really important, and if you do not desire to get vaccinated for yourself, consider doing it for herd immunity reasons, because not everyone can. People can be too old, people can be too young, people can be too immunosuppressed. And you can gain immunity through vaccination. So, herd immunity, right? In the interest of time, we'll skip this. Preventing future infectious disease pandemics. What do we need to prevent the next global pandemic? We got to shut down or strictly regulate commercial wildlife trade and markets that pose health risks. We do need to stop deforestation and forest degradation. Also mitigate climate change overall as well. I think this is like a step toward that. We need those forests. Improve livestock health, strengthen veterinary care and biosecurity and animal husbandry. Provide better healthcare and alternative livelihoods to communities living close to wildlife in tropical regions. Enhance surveillance for zoonotic viruses at the interfaces between humans, domestic animals, and wildlife. Yo. Again, I think about this every time there's a state fair and I see people eating meat on a stick and next to the pen with the pigs in it and a porta potty. Enjoy your state fair though. Heat map. Oh yeah, I was just talking about this. Here's a heat map of relative risk of zoonotic we'll talk about what relative risk is soon. Of zoonotic emerging infectious disease occurrence. One thing you'll notice is we're bright yellow. Part of the reason we're bright yellow is because LA is so highly concentrated and also because of our mosquito problem. High concentration of people, mosquitoes, we have high risk of emerging infection disease occurrence. So pour out your water, get your vaccines, don't stress out your animals. Other things we can do are improve global coordination and leadership. Infectious disease spread often does not happen in a vacuum in one country or region. Viruses don't give a fuck about borders. They will hop right over. So we do need global coordination and leadership. Invest in global pandemic preparedness and response. Man, it's such a bummer. I think the vaccine injury is valid, and we could have used the pandemic as a means of creating a registry for real vaccine injury. We didn't do that. Um, a lot of people, I think, are more agitated by public health than before due to the communication of the pandemic. There was a lot of tension between the government and the CDC, and then what got told to the people was kind of like a weird, dilute, not all the way there message. So, um, that's neither here nor there. Improve global infrastructure to monitor and develop coordinated responses to disease threats, which responds to better and more responsive surveillance. And better, sometimes more research on emerging threats, vaccine development, and disease treatment. The TLDR being have good systems in place in every sector of public health and policy. All right, that's it for lecture. Your community activity is the Jamboard. It's already linked in your Canvas module. Very similar to what we'll be doing for history, or what we did for historical figures. Each page is about an infectious disease. And as a class, I'd love for you to work together and fill each page with stickies about each disease. Here are some questions you might look up. What pathogen causes the disease? How is it distributed in the global population? Like who is getting it? What regions? What age group? What are the different modes of transmission for the disease? Is it mosquito-borne? Do people also get it through, is it sexually transmitted, A, B, and C? What environmental, animal, and human factors drive the spread of the infectious disease you chose? Maybe flooding is like a really salient one. And maybe add the picture of the microbe or the giant microbe plush. I've already got you started with the first two. Have the giant microbes. You're welcome. Some of them that don't have it, I like put a different picture. I've only helped in the amount of pictures. So have fun adding pictures as well. With the caveat that please no pictures of real people / patients. Describe a rash versus showing it. And I'll freeze and download the Jamboard on Monday night for you to use as a resource on your final exam. I'll also do the same soon with the historical figures one. If you were still motivated to go back and flesh that out, you can. Yeah, so that's your activity. I figured we can all do that from home. Enjoy our big computers and watch TV while we're doing it. So there you go. That's your Jamboard activity. And next week, quiz 4. Okay, so thank you for bearing with me as well with the change this week. Again, I wanted to goof off. I'm scared of COVID. But next week, quiz 4 will be due Tuesday, so you have the entire today, tomorrow, the weekend, Monday to do it. And it's due when I next stream lecture on Tuesday, okay, on the 27th. I think it's a quick and easy one. You probably could have cranked it out during this lecture. So quiz 4 is due Tuesday, and then we're back to our regularly scheduled programming, back to live stream lecture on Tuesday and activity on Thursday. Unit 1 homework is also due next Thursday on Leap Day. I think I've made it due at 5 p.m. I don't like when people are like up until midnight about it. Again, you've been given plenty of time to work on it. And plenty of resources, and should you want my help, I'm still here for you. If there are extenuating circumstances, let me know if you don't think you're going to get it in on time. Again, I'm very graceful and gracious with that. Just communicate to me what's up. It's due next Thursday. And next week, I suggest that you tune into lecture live if you can, or as soon as possible if you can, and come to activity, because during lecture, I'll be introducing an extra credit opportunity. It's not going to make sense if I talk about it now because it has to do with next week's lecture. And we'll be completing it on Thursday, and then I think it'll be due the week after. So you have an extra week, like next Thursday. So if Unit 1 homework is due next Thursday, then the extra credit will be due next Thursday, right? Okay, let's real quick. Oh, I don't know what's going to show if I do full camera. Not that much. My bed's not made because of the TAs. There's one. And then here's the other. Let's do the Wordle real quick and the connections. And if you have any questions about infectious disease epidemiology or the run of the show, course administration, when things are due, I'm right here for you. Let's do this Wordle. What am I being advertised? How can I turn this advertisement off? No. Well, you're going to be advertised to as well. What's a good 5-letter word that we've talked about today? It's kind of a horrible word to start with, but let's start with the word screen. Nope, that's too many letters. What's a good 5-letter word? Let's guess ticks. I know that probably S won't be at the end, but let's guess ticks. No, let's guess agent. Let's guess agent. That's a good 5-letter word. Okay. Oh, I wanted to do learn, but the N is gone, so let's do weary. How interesting. Let's go heady. Let's go heavy. Easy clap. Oh, you said virus. That would have been such a good one. Let's see if I remember that for next week. Next week, word is virus. Okay. We got... Virus would have been a good one because we could have gotten that V. Your mind. Okay, let's pull up the connections. Oh, hi, Niam. Oh, I just pulled up regular New York Times. MIT connections. I do really miss all of you in person. Okay. What have we got? Ooh. Growl, bark, whine, and howl. Those are all things that dogs do. Those are all sounds that dogs make. I think that that is one. Yeah, okay. Now, preen is really interesting. That's like what a bird does, right, when it's cleaning. Chapter, source, font? Like things that you would see in like a Microsoft Word window? And clue? Okay, mellow is like calm. Okay, preen, wing. Those are bird words. Cradle, maybe? Okay, source, root, branch. This has to all be one. I think it might be branch, arm, wing. Branch, arm, wing. I showed up to class because I didn't read. You gotta have those Canvas announcements on. You gotta have those Canvas announcements on, and you gotta text the homies. When something like this happens and like a class gets moved and you see it, it's not on you obviously, but tell the homies next time to tell you. And you could also plug me into the big screen if you want to, if there's more people in the same boat as you. Yo, kind of a hard connections today. Why am I so concerned about font and chapter? Like sections, source. Branch, arm, wing. Cradle? Like things that reach out? What about frown? Preen? Frown? I'm still thinking about like things. Alright, I'm going for this. Cradle, branch, arm, wing. I don't know what it would be. Oh, I'm one away. Damn. Uh, hmm. Source, maybe? Oh, I'm blowing it. Chapter. It's definitely chapter. This is, it's gonna be like groups of people. For some reason, I thought it was like things that reach out, but these are like infantry. My brothers in arms. Yeah, department. Okay. We need to not blow it now. Source, root, cradle. Yo, font makes no sense. No way. Okay, well I got it, but that was a lucky. That was a lucky guess. What is it? Colors with their first letters changed? No way, bro. That's crap. Okay, thanks for coming to lecture. Please reach out if you have any questions. And have a great rest of your day and a great weekend. And I'll see you on Tuesday. Bye bye.